Hello, this is a brief review of changing the DATS fouling monitor heat exchanger tube to educate you on how you can do that process in the field. This is the DATS heat exchanger on a bench, and let me start just at the beginning. This heat exchanger tube change, there's a number of reasons you might want it changed, but the basic procedure is to pull the cover and the end plates off. So I've already removed the Phillips head screws. The cover lifts off after the 4 Phillips head screws are removed. 3 screws on either of the end plates come off so that they slide out after loosening this connector. You have to pay particular attention to this end plate because the ground wire is connected on the inside. Okay, to remove the main insulation, you need to rotate it out of the heat exchanger box like so, lifting it out. Some of the smaller insulation pieces will come out with this upper insulation, which basically looks like this. Now if you could come over and look right inside here, you'll see the heat exchanger core in place inside the system. Okay, so with the core of the heat exchanger exposed, we've got the power connections here and the 2 temperature sensors. Also, I want to note that there is a ground wire here that is connected, I didn't show that earlier, to the end plate, so ensure that's set to one side. The main heater power connections are taken off one at a time. You notice the ground is in the center, green on one side that goes to the heater element and black on the other side. Either side can be removed. And then the power is the red and the blue. So on 240 volt systems, they're both hot, and on 120 volt, one is hot and one is neutral. So just by loosening these, get this disconnected. Now to remove the temperature sensors, just with thumb pressure should be all that's required. To loosen the connector, pull the temperature sensor out, and you'll notice the white thermal grease on the end of it. That's fine, just set it to one side. The same with the block temperature sensor. And it should, with a little bit of friction, pull out. Again, set it to one side. Now with those removed, you're able to lift the entire heat exchanger core out of the heat exchanger box, and you have it loose. Okay, so with the heat exchanger core out, we have our ratchet wrench and the 4 clamps to remove. We'll loosen them first, pulling the clamps off. You'll notice they have the Belleville springs on there. You don't have to be worried about the torque right now. We'll remove the rest of these off of here. Okay, so with the clamps removed from the block, the inlet block and the heater block, we take our wedge and hammer and drive this gently into the tube. The clamp might be on there too tight, so just press gently in either direction and you should be able to slide off the inlet block. Similarly, we can do the same with the main heater block. And let's just give that a try right now. Again, push both directions. I've got a little grit on this table here. Oh, she's on there pretty good. There we go. And sometimes a little more persuasion is required. Gently remove the tube from the block and ensure that you have no sharp edges on the end of the tube, which will damage the soft aluminum heater block. This is what the heat transfer paste should appear like beneath the heater block, showing that you've had a good clamp and intimate thermal connection with both those components. Okay, so if you've purchased your spare heat exchanger tube from Bridger Scientific, it should be pre-marked with the locations of the heater block and the inlet block, roughly, so that they fit in the insulation that's already been cut. Okay, the next step is to use your heat transfer paste and smear it on the exterior of the tube. This tube has already been sanded smooth and any burrs removed. So only a small quantity of this heat transfer paste is required here, and applied judiciously, we remove any extra off. The heater block is the most important component, but the inlet block also requires it for more intimate surface. To smear this grease, we're looking for just a translucent layer of material beneath the heater block itself, and a little over either edge is fine. And you'll note why we've got the markings for the inlet and heater block a little bit wider so that we can ensure we've got the proper location and full coverage. This is important to get this material on the right thickness and that the tube is blemish free, particularly in this area, so that the temperature of the block is stable and uniform. So that is about what it should look like before clamping. Almost translucent layer. Okay, so the heater block has been cleaned on the inside and inspected to ensure that it's blemish free, and it's now, and the inside or the edge of the tube is not sharp, and now we gradually and carefully introduce this tube and block together, slide it over to the appropriate position, and wiggle our wedge out of place. The block clamps closed slightly, but not entirely. So it's important not to move the tube about as you're doing this. Now we'll put the clamps on the OD of the block and holding it in place. Okay, so the clamps have been placed back on the tube and it has been prepared for installation back in the heat exchanger enclosure. You'll note that I've put both seams of the block in the same relative location so that the inlet temperatures are on the same spot. It's not imperative, but it's desirable. The block and heat exchanger core is just placed inside. Then the heater block temperature sensor is inserted and the inlet block temperature sensor is inserted. And the rest of the process is the repeat of what we just did, taking it apart with the insulation placed back on top and rotated into place, the end covers, and then the top cover placed on. Then after that, put the system into service, get to your equilibrium flow velocity and heat flux, and zero the heat transfer resistance for your new tube so that your percent clean and your wall temperature will be accurate. And that's about it.